Aloha, this is ITS128, and today is September 17th, and so let me share my screen. Number 2. All right. So today we are, let's look at this thing. This is this class, and we're going to start chapter 4 today. So we're doing class number 8. I'll probably put class number 8 down here, I guess. And so I guess we're going to, yeah, we have, we're actually ahead of the game here. So we'll see how this goes. Anyway, all right. So chapter 4. Okay, so now we're starting to get into branches. How you're going to test something, and if something is a particular greater than something, then we're going to go do one thing. Otherwise, we'll do something else. And so I just figured out there's this present mode here. And so we're in chapter 4, the beginning of chapter 4. And so to start out, we talk about this concept, the branching concept, and imagine that you're a restaurant host and you seat patrons. And so, you know, if it's just one person, you seat the person at the counter. If it's a party of 2, you seat them at these tables that take 2. And if it's more than that, more than 2, they're seated at a large table. And so mentally, this host executes this algorithm. If party of 1, let me open up the chat just in case someone wants to say something to me. So the host thinks if it's a party of 1, you seat him at the counter. Party of 2, seat him at the table. Otherwise, seat him at the large table. Okay, so what am I supposed to do? 1 counter. Oh, party of 2 comes in, and put the person there. 4 comes in like that. Okay, great. All right. So here's okay. So that's an algorithm, and it's like this is actually how the program sort of looks. You have this: if party equals 1, then do this. Otherwise, if party equals 2, then do this. Otherwise, do this. So here's another example, a hotel discount, and let's say that the branch path taken if the expression is true. So you look at the person's ID and you see how old they are, and if their age is greater than 60, then you deduct $20 from the price. Otherwise, you don't deduct $20 from the price. You skip this and you just go straight down to here and you put the cost in the output. So here we have this example. Somebody comes in and they're 72, so it goes there and subtracts $20. Someone comes in and they're 45, they don't subtract the $20. Anyway, so great. Here's one where you're computing the absolute value. This is an example of how, if you don't have an absolute value function, you can do it manually like this. And so you read in the number, and if the number is less than 0, then you make it the minus of it. Okay. Otherwise, if the number is not less than 0, then you don't do anything to it. You just keep on going. Okay. So this is like an if branch. There's else branches. There's if else branches, and this sort of illustrates that, where let's say you if somebody weighs less than, if the input weight is less than $50 or 150, then you can't ride. If the weight is if the weight is not less than 150, then you can ride. So here, if the weight is 128, then it's less than 50, so it ends up doing this one, and it says you. Oh no, never mind. If you are less than 150, then you can ride. Otherwise, you can't ride. So if someone comes along and they're 128, well, that's less than 150, so this thing is output. And someone else comes in and they weigh 175, and then they're not less than 150, so it takes this path, and it outputs can't ride, and then it outputs done. When it's completed with either of these, it prints out done. So here's a little algorithm to figure out. You take two inputs and you output the maximum. So you input, x and y. If x is greater than y, then you know the maximum is x. Otherwise, the maximum is y. So if it's x is 7 and y is 3, then it's going to know that 7 is output. If it's this way, it's going to know that 7 is output. So you can cascade these. You can cascade these if statements. So you have if something, else if something, else if something, else if something else. See, so in this one here, you're saying you get the year, and you see if the year equals 1984, and if it equals 1984, then you say Orwell. If you say if it's not equal to 1984, then it does this one, and here it tests to see if the year is 2001. If it is, it prints this out. If it's not, then it does this. Now, if it is 184, then when it's done, it goes down to here. It skips all this stuff. If it's not 1984, but it is 2001, then it does this, and then it skips the last thing. If it's neither of these, it's going to do the else, and it's going to put nothing special. So that's if. So we've done if that, or if, and then we've done if else, and this is if else if, and you can have as many else ifs in the middle as you want, as you need. Yes, somebody just asked, can you use greater than or equal to, less than or equal to in the if clause, namely right here. Oh, here we're using greater than. Yes, you can, and in fact, this book or this text here, it introduces you to it before it talks about it. It actually talks about it in like a later section. Here we go. Here we're starting to talk about the operators for where it's an operator, and when the operation is done, it's either true or false. It's not like the plus operator where the result is going to be like you add the two things together. It's for double equals, it's comparing the two, and if they are equal, the whole expression evaluates to true. Otherwise, it evaluates to false. So, all right. So here, are we summarizing this? I guess so. If else, yeah. So you read in the age, and by the way, have we seen this yet? When you use this input function, when you put something inside those parentheses, string, that string is displayed out. So when this thing executes, it looks like this. First, it sets hotel rate to 155. Then it executes this. And what that is it displays this out, enter age, and it sits there and waits for the user to type something in, and the user types in 68, the character 6 followed by the character 8, and then so that's the character 6 followed by the character 8. It's converted to an integer value of 68, and that's stored into this user age variable. And this tests to see if user age is greater than 65, and if it is, it subtracts 20. If not, it skips it, and it prints out whatever hotel rate is. Hotel rate is either going to stay 155, or it's going to, or you're going to subtract 20 from it. And then here you display it out. So this is how this is illustrated from what we've seen before. So if user age is greater than 65, it takes this branch around here, which does this additional calculation, and then it drops down and then displays this out. And with if else, you have if and then an expression, and then all the statements are indented here, indented in there. And then you have this else word, and then all the statements that are executed if the expression evaluates to false. So here, for example, we have an expression. If it evaluates to true, it sets your insurance price at so if you're less than 25 years old, then your insurance price is 48. Oh, this must be for like car insurance. Okay, I was thinking, life insurance. So if you're under the age of 25, presumably you're a higher risk, and your car insurance is going to be higher. Otherwise, if you're age 25 or over, if you're age 25, this evaluates to false. If it's 24, it evaluates to true. If it's 25, it evaluates to false. If it's 26, 27, 28, it evaluates to false, and your insurance price is going to be that. So in the Python interpreter over here, we have a little memory slot here that's insurance price, and another memory slot that's user age, and so that's how that looks. All right, and here we see this input, and it looks like that. Okay, so here's a challenge activity, and so by the way, I'm reviewing this conference paper for this conference. That's this computer science and education conference, and it's happened. Oh, where is it? Well, anyway, it is a paper on studying these interactive textbooks. Zybooks is an interactive textbook. And so this is a paper on, they're trying to study and model how students do. They want to measure how much you interact with the textbook, and how that correlates, if that can predict how well you do, how well you learn, your grade. So the paper here, where's the paper? Oh, I gotta go. I was going to show you the paper. Where is it? Here. Oh, never mind. Download submissions. Let's That's right. This is kind of relevant. So we are using an interactive computing textbook. And here's a list of some of the interactive computing textbooks, and Zybooks is one of them. And what's great about Zybooks is this interactive part where there's visualizations. There's not really slides. Not sure what that is actually, but there's animations, there's practice sets. You're able to write your own code and execute it, and you take some quizzes and so on. Their test was using this Jupyter system where you can put in code from scratch. With Zybooks, you can't really put in code from scratch, but they found interactive textbooks have been shown to have a substantial impact on performance. And there's a multi-institutional study, and it especially helped with the class's lower quartile. In other words, the students that may lose interest for whatever reason, kids are running around or something, and this, that's usually at your age. It's when you don't do well, it's because you're so damn busy. It's not because you don't have the brains or anything. And so this way of teaching it in these short little chunks, and you do stuff, and you're challenged a little bit. And so they found that these kinds of textbooks are really good, and the students seem to like them. They compared. Well, anyway, so that's actually pretty interesting, and I'll let you know more as the semester goes on, because I am kind of interested in this as a way of improving, making learning more fun. So anyways, so let's do this challenge activity. Number of apples is 6. If the number of apples is less than 2, oh no, we have to press start first. Okay. Number of apples is 5. If number of apples is less than 8, then print C. Okay, so number of apples is less than 8, so we print a C. And then we print an H. Oh, all right. I'm supposed to print another return there because this. All right, let's try it again. Oh, gives me another chance. There we go. All right. If the number of cats is greater than 7, print a C. Otherwise, it's not greater than 7. It's less than. It is not greater than 7. It is 7 or less. It's 5. So I'm just going to print a C, and then we're going to print an H, and then we're going to print a return. Uh-oh. Oh, it's not less than sorry. I was just seeing if you're awake. All right, so is it greater than 8? No, it's not. It's an E. I got to do E this time, and then H. All right. Well, you can do that one. Oh, challenge activity. Okay, now we're actually going to write code, maybe. Write an expression that will cause the following code to print 18 or less if the value of user age is 18 or less. Okay, so if user age equals 18 or user age is less than 18, then print 18 or less. Yeah, it works. Of course, this is a silly way to do it. It's better just to do if less than or equal to 18. Or, this works, Or if we haven't learned this sort of this compound conditional thing here, we could do if it's less than 19, because we're talking about integers. So this would work too. All right, next one, basic if else. If user tickets is less than 5, guess so. Fewer than 5. Assign number of tickets equal to 1. Otherwise, less. Huh? Okay. All right. So you read in user tickets, and if it's what if user tickets is less than 5, then assign. You can actually do this. Num tickets equals 1. Else num tickets equals user tickets. See if this works. Yeah, it does. So you don't always have to indent. You don't always have to. I think if you had more than one thing, you know, if you can't, what happens if I do this? Yeah, no, if I want to put something else here, if when user tickets is less than 5, if I wanted to do more than one thing, I don't think I'd be able to do this. I'd have to do this. All right, so anyway, multi-branch if else. Only one branch will execute. Yes, only one branch will execute. Yep. Okay, so there's this equality operator which evaluates to true if the left side and the right side are equal, of course. So here's an example of where you read in the number of years. It's an integer. If it's equal to 1, you do something. Otherwise, if it's equal to 10, you do something, or if it's equal to 25, you do something, or if it's equal to 50, you do something, or you do nothing, or you display out nothing special. So it's going to do one of these because it's exactly one. It's not going to do more than one. All right, write an if-else statement with multiple branches. Multiple branches. If the year is, so if I got this year thing I just read in here, and I do if year is equal to 2101 or later, then print distant future. So if it's greater than or equal to 2101, do that. All right. Else, so it's elif, right? Elif. It's weird. Elif. Elif, if it's 2001 or greater, year is greater than or equal to 2001, then you do something different. You say print 21st century. Okay, and you can fill in the rest. And so you do one more, I think, or yeah, and then you do else print long ago. And of course, this is not complete. You can make it complete, but let's see what this looks like. Okay, so right, so yeah, it works with 1776. It works with 1900. It looks like, yes, but it's not going to work with 1901 because at 1901 it's supposed to display out 20th century, and so anyway, so you have to put in one more to make it work for 1901. Between 2000 and 1901. All right. Okay, now we're going to do nested if-else. See, before it was just all kind of in a straight, all kind of, you have a bunch of them here, and it's just going to do one of this. Now, when we're talking about nested ifs, here we have it where if this ends up the case, then you have some more. You actually have an if inside. Okay. So, for example, in this case, well, what this program does is, if the user choice is equal to 1, then it just prints that out. If the user choice is equal to 2, then it looks at the number of items. Only if the user choice is equal to 2, though. So if the user choice is equal to 2, then it looks at the number of items, and if the number of items is less than 0, then it's going to do this. Otherwise, if it's 0 or greater, then it's going to print out this, and then it's going to go to the end. So that's if user choice is equal to 1, and so that takes care of user choice equal to 1 or user choice equal to 2. If user choice is equal to something other than 1 or 2, it's going to do this else, and it's going to print out user choice is neither 1 or 2. All right. So that's a nested if. Here, this is another case where you can have just separate, distinct if statements. In this case, they're independent. So one may hit, and more than one may hit. None of them may hit. And so, for example, if you are, okay, so this is less than 16, greater than 15. Okay, so these don't. It's either going to be this one or this one, because yeah, if it's 15, right? If it's from 0 to 15, it's going to display out this. If it's greater than 15, it's going to display out this. Now, if it's greater than 17, so it's going to print out this. If it's greater than 24, it's going to print out this. If it's greater than 34, it's going to print out this. So if it's 35, if you are 35, this one's going to hit, this one's going to hit, this one's going to hit, and this one's going to hit. See? Whatever. All right, challenge activity. Number of items equals 5. If the number of items is greater than 2, yes. Well, let's do one of them. Number of items is greater than 3. Okay, it's 5, so it's greater than 3. So you print out B, and then you're done. So then you print out P. Okay. Now, you notice that since it's 5, this never gets checked. Even though this is true also, this one was true first. Okay. You'll see how that comes into play later. All right. Write multiple if statements. If the car year is 1969 or earlier, you do something. If it's 1970 or later, you do something else. If it's 1990 or later, it does something else. And if it's 2000 or later, it does even something else. And these are multiple if statements, okay? So that means it can be more than that, that more than one of them can hit, okay, basically is what they're trying to tell you. So you do if car year is equal to, no, is 1969 or earlier. So if it's less than or equal to 1969, then print few safety features, period. Okay, so that's that. Done with that one. Now, if car year is greater than or equal to 1970, then print probably has seat belts. Okay, that's good. Now, if car year is greater than or equal to is 1990 or later, greater than, later than or equal to 1990, then print probably has anti-lock brakes. I think there's a period here. Finally, if car year is greater than or equal to 2000, then print probably has airbags. All right. Looking good. All right. Cool. All right, very good. What's next? It's 348. Let's keep moving. Equality and relational operators. Equality operator. The equality operator checks if two operands are equal or not equal. Not equal. A Boolean is a type that just has two values, true or false. So, you know how a variable can be an integer, it can be a floating point number, it can be a character string. It can also be a Boolean. A Boolean can only be true or false. And so, and you can see that, so you can actually have expressions. You can actually have Boolean you can actually have, well, we'll see that. Anyway, so Boolean is a type of variable that just has two values. Well, so this is gonna evaluate to a Boolean value. So that expression is going to evaluate to either true or false. So is this one. It's either going to be true or false, depending on what A and B are. Again, depending on what A and B are, it's going to be true or false. So this is A is greater than B. This is A is less than or equal to B. This is A is greater than or equal to B. Right. Enter. And let's see, here we go. Now we see this enter a number. So that gets displayed out. And then this is what gets entered in. And then this gets executed. So yeah, put 0 here, of course. Okay, here's a challenge activity. All right. Oh, here we're just learning about less than or equal to. See, we already know about that though, right? Number of eggs is equal to 4. If the number of eggs is less than or equal to 6, then print A. G. All right, you can do the rest of them. Write an expression that will print $1 or more if the value of num cents is at least $1. So so if the value of num cents is equal to 100, you can do your solution goes here. So you put num cents is equal to $1 or num cents is greater than 100. Well, of course, you don't have to do that. You can combine the equal sign and the greater than, put those together, and I guess you have to put the greater than sign before the equal sign. So what would happen if I did this? I'm going to take this out of here. What would happen if I said equal or greater than? See if this works. I bet it doesn't work. No, it doesn't work. It doesn't like this. It's got to be greater than or equal. So how about if I do greater than 99? Oh, look, it worked. Huh, okay. Well, really what they're looking for is, this. Operator chaining. Write an expression that will print in high school if the value of user grade is between 9. Oh, this is that operator. Did we talk about this yet? We haven't talked. Okay, I think this is what they're talking about. If user grade, if user grade is no, maybe we're not talking about what I'm thinking here. Okay, if user grade is greater than or equal to 9, and user grade is less than or equal to 12. But you can also do user grade you can do 12 is less than or equal to user grade is to 9. You do this too. So user grade is in between 9 and 12. Isn't that cool? I don't know of any other language that lets you do that. So anyway, a couple ways you can do that, but that's not what they're looking for. I'm quite sure what they're looking for was what I had before. If user grade is greater than or equal to 9, and I wonder if this works. Is that good for and? No, it doesn't work for and. I'm gonna do this. How about this? Does that work? No, it doesn't work. Okay, ampersand must mean something. Single ampersand, I think I probably know what it is. Anyway, so what's next? A Boolean refers to a value that is either true or false. Okay, so here you are defining a variable, and it's going to be a Boolean variable. And so a Boolean variable is going to have the value of true or false. And so here you're assigning it to true. It's got to be a capital T. Okay. So here, okay, here we have a variable and we're assigning it the value true. It's a Boolean variable. Here we have a variable and it's an integer variable. We're assigning it the value 5. Now here, this is going to be this thing. This is either going to be true or false. So that evaluates to a Boolean value. So this is going to be a Boolean variable. This is going to be either true or false. It's actually going to be false because my val is not less than 3. All right. So, now we have and, or, and not. So I've already shown you and or. Okay, so this is and you should know this from ITS128 or some high school. You probably had this in a logic class or philosophy class or whatever. So it's, if you have two Boolean values, and if they're both false, then A and B is false. They both have to be true for them both to be ANDed together to be true. Whereas with or, only one of them has to be true. If they're both false, then the whole thing's false. But if one of them is true, then A or B is true. And then, of course, not is the inverse thing. So here's some examples. All right, so and, or, and not. So here is where it's being used. So here we have if age is great. So if age is greater than 16 and age is less than 25, then that means if the person is 17 or 18 or 19 or 20 or 21 or 22 or 23 or 24, then it's true. Then this whole thing is true. If the person is 16 years old, or the person is 14 years old, or the person is 25 or 26 or 27, it's going to be false. Okay, here, yeah, so here we're using examples here. This test to see if it's equal to Q. It is equal to Q, and so the not of it is going to be false. All right, so here we're learning about this. We're showing we know how to use it. So x is equal to 1. Oh, let's start it. Okay. X is equal to 7. If x is less than 7, well, we already know this is false, so we can just go right to here and print B. See, because with an and, once we see this is false, it doesn't matter what this is, because if this is false, then the whole thing's going to be false, and so it's not going to do this. It's going to jump down to the else. So is that right? Yes. All right. X is equal to 7. Let's see, this is true. Well then, if this is true and it's an or, then we already know it's true. It doesn't matter what this is. So it's going to print A. Yep. Let's do one more. Okay, x is equal to 2. If, okay, x is equal to 2. So this is going to be false, because x is not greater than or equal to 5. This is false, but it's not. So that means so not false means true. So A is going to print. We already know A is going to print. Now what's the next one? Is x less than or equal to 9? Yes, it is. So this is true. Not true. Not true means means false. So this whole thing is false. So the B is not going to be printed, but the C will. Is that right? Yes. All right. What's next? Let's go down here. Write an expression using Boolean operators that prints special number if special num is -99 or 0 or 44. All right. If special num is equal to -99 or special num is equal to 0 or special num is equal to 44. Yes, it's that easy. Write an expression using Boolean operators that prints eligible if the user age is greater than 17 and not equal to 25. All right. Well, so the person is greater than 17. So anything greater than 17 except 25. So user age is greater than 17 and user age is not equal to 25. All right, I gotta leave something for you to do here. So write an expression that prints "you must be rich" if the variables young and famous are both true. Okay, so the way this works is you're supposed to type in, you know, thing runs, it doesn't display anything out, it just expects you to know what you're supposed to type in, and you type in true if young is true, and you type in false if young is not true, and you type in, and then waits for you again to type something else in, and and if you print true, then famous will end up being true, and false, if you print false, then famous, or if you print, you only have to type in true. If you don't type in true, it's going to take it as false. Okay, so it evaluates this here. So it takes the input, it takes what the person typed in, and it sees if that string is this. If it is that, then true is going to equal, young is going to be equal to true because this is true. If it's anything other than this, then this is not going to be true. It's going to be false, in which case young, the value of young is going to be false. So both of the variables have to be true. So you just have to put an expression there that tests if both variables are true. If young is true and famous is true, then it displays out "you must be rich." If either one of those is not true, then it's not going to print out this. It's going to print out this. Okay. All right, membership and identity operators. operators. All right, so this is something that's not in lots of languages, but it's in Python. So there's this in operator and not in. Okay, so so the in and not in operators, known as membership operators, yield true or false if the left operand matches the value of some element in the right operand, which is always a container. It's a container. The in and not operators, known as membership operator. Oh, I already read that. Oh, not in. Okay, not. Membership operators, in and not. All right, so here we have this set. I guess it's a set, and it displays out this. I guess I can. Why don't I pull up? Let me clear this. So let's just take. Let's take this code. Let me just PHP. So let's just take this and see what this looks like when we run it. Copy this, paste it here, save as test.py. Yes, replace it. And let me pull up a CMD. CD desktop. And so if I do Python test.py, enter a name to check. All right, so I'm going to do Joe. Nope, Joe's not in the roster. Let's try it again. How about Fabregas? Ooh, Fabregas is in the roster. All right. So you see how that works? If the name is in this, which is this, then it says that. Otherwise, it doesn't. Okay, anyway, okay, substring. Checking for substrings. So it's this in operator. And it treats every character like it's like a set of characters. So it's checking to see if this substring is in this string. Is this in this? Well, let's see. This is this, and oh look, there it is. So it should say it's HTTP protocol 1.1. All right. This is a dictionary. So if B is in my dictionary, so it's looking for this. So this is not in the dictionary because it's not looking at the values. It's looking for the names, the indexes, or the key. So there's is. So these are operators that you don't find in other languages. So you might not use them that often unless you're choosing Python to solve a problem because it has these features, which is possible. All right, so here's a challenge activity. Start. Okay, okay. All right. Numbers. Input. The input is 7. Is 7 in numbers? No. Yeah, is 7 in numbers? I think it is, yeah. In, right? Oh, good. All right, what's next? Isn't this just in again? Okay, so it reads in a vowel, which is E. Vowel is equal to E. Word is equal to bell. So if vowel is in word, it is in word. So it's going to do in. I think. Yeah. Okay, you can do this one. So we have D here. Is C in D? Oh. Uh, so D is. Oh. Nice. Well, that's interesting. I wonder what the answer is to that one. Is AB in AB? Oh, wait a minute. Oh, D is changed. D gets changed. Well, I'm going to let you just work on that, and you can just guess until you get the right answer. All right. Write an expression using membership operators. Oh, this is. Oh, now we're going to do this one with membership operators. Okay, great. So I can do if special num in special list. Is that right? Oh, yes. So there's order of evaluation. There's operator precedence in these Boolean expressions also. Well, we learned about, well, anyway, when you have this expression with a bunch of operators in it, you don't necessarily evaluate the expression just from left to right. Multiplication has precedence over addition. If there's parentheses, you do what's inside the parentheses first. And, these relational operators have, have precedence also, have an order of precedence also. And so if you're in doubt, just put parentheses. You can, parentheses will override anything. So if you want to make sure that something is evaluated in a particular order, like do this one first, then just put the parentheses around there. So, for example, and has precedence over or. Okay, you can kind of think of and like multiplication, and or like addition. As true or false is true, but true and false is false. It's got to be true and true to be true. So it's kind of like anding. It's kind of like multiplication. Well, that has precedence over or, just like multiplication has precedence over addition. So when you write something like this, it's going to do, well, no, it's going to do the, well, it does these, it evaluates this first, and then it evaluates this, and then it evaluates this, and then it's going to evaluate this here because and comes after that, and then it'll evaluate the or here. So um, see is so it first it does these because they have precedence, okay? And then it does the and. You see the parentheses indicates that that's next, and then the last thing it does is the or. So if you write this, and really you want to do, you know, this first, evaluate that, and then evaluate this and do the and last, you have to put parentheses. So you would do this here, but you would put parentheses around here and here, and then take off this one and this one. So anyway, so here's a way of looking at it. It's going to do, it'll do this. So first it's going to do, well, anyway, you can go through this and see. It'll first do these calculations, and then it'll do these evaluations, and then the last thing it'll do is the or. So anyway, what's next? Code blocks and indentation. Okay, I guess it's time for us to pay attention to this. Code blocks are indicated with indentation. It's the only language that does this, okay? I'm sure that I can't think of any other language where indentation matters. That's how you indicate blocks. Okay, so now when you see code written in other languages, there's indenting. There's no doubt about that, but it's just for the programmer to see it in an organized way, and because indenting is a good way of keeping track of nesting and blocks and so on. It's just that with Python you have to do it right, and you have to be careful with, sometimes your editor will put a tab there instead of like 4 spaces, and that'll screw up the Python interpreter. So you got to pay attention to that too. Okay, so it's going to just do these one right after the other, do this and do this. And for here, it's only going to execute this block if this is true. Here, it's only going to execute this block if this is true. And so on. Here, it's only going to execute this block if this is true and this is true. So anyway, now with these simple programs that we're doing now, we don't have to worry too much about indentation, but because it's going to be simple, just going to be 1 or 2 levels. But when things get more complicated, then you will find that you'll sometimes have errors in your program because the indentation isn't right. All right, here's a challenge activity. Retype the code below. Fix the indentation as necessary to make the program work. Okay, so well, this is all messed up. Okay, so basically we're supposed to take this, copy, and put it here. If New York is in temperatures, it is, then if temperatures of New York is greater than 90, then print the city is melting. Otherwise, print the temperature in New York is whatever it is. Otherwise, otherwise, the temperature in New York is unknown. So what happens if where do we read it in? Oh no, it's just right here. Okay, so let's, so what happens if I copy this, copy, and I paste, let's see, save, No idea, it doesn't work. New York. Didn't like the New York. If this must not be right then. This is, oh, this is, oh, it's asking me for an input. That's why it didn't work. Ah, no wonder. Okay, let's go back. Okay, let's try this again. Okay, 105. The city's, okay. See, this is so dumb. You should put in here, enter. Oh, you can't. All right, forget it then. I won't do that. I should put in, enter a temperature value for New York, fool. Okay, save. Enter a value for New York. Okay, so what is it? If it's greater than 90. Okay, so what if I put 91? Ooh, what if I put 90? Okay. And what if I put, oh, it's always going to be in there. Okay, well. All right, so anyway, that's great. Wonderful. All right, what's next? Conditional expressions. Oh, this is new. Where are we anyway? Conditional expressions. Oh. Oh. What am I doing? All right, we are in 4. Conditional expressions are way down at the bottom. Okay, is that it? 425. Okay, so I can just go over that, and then we can start with this next time. Okay, conditional expressions. So you can do this in Python, where a variable is equal to an expression if this condition is true. Otherwise, it's this. So this is kind of like the operator. This is like the operator. It's like my var is either going to be equal to this expression or this expression, one or the other, depending on how this evaluates. So your number is equal to, okay, if my number is equal to 10, then it's going to be 2. Otherwise, it's going to be 13. So it's going to be 2. All right. In this case, if my number is less than 4, okay, is that true or false? It's false, because my number is equal to 4. It's not less than 4. So that means it's going to be the else one. So my number is going to equal 2. This one, 2. And this last one here is, okay, if my number is 6, so this is false. So your number is going to be equal to my number plus 4. So 6 plus 4 is 10. So your number is going to be equal to 10, I believe. Yeah. Okay. Create a conditional expression that evaluates the string, evaluates to string negative if user val is less than 0 and non-negative otherwise. So the conditional string is, it's going to be equal to negative if user val is less than 0, else it's going to say non-negative. Let's see if this works. Yeah, it works. All right, that was easy. Using, I'm not going to do this one for you, but I'm going to see if we can make sure we understand it. Using a conditional expression, write a statement that increments num users if update direction is 3. Otherwise, it decrements num users. So first, it's going to read in num users, and then it's going to read in update direction. And if update direction is 3, then it's going to increment num users. Otherwise, it's going to decrement num users. So you're going to have here, it's either going to be, if some expression is true, it's going to be num users plus 1, and then some expression, blah, 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 else. And then this one is going to be num users minus 1. Okay, so you have to fill in this. It's going to be if something. And if that thing is true, in other words, if whatever it is true, then it's going to do this incrementing thing where it's going to set num users equals num users plus 1. Otherwise, if this evaluates to false, it's going to set num users equal to num users minus 1. All right, so you should be able to figure that out. So how is that? So it looks like we've covered pretty much everything in the chapter except for this additional practice thing. We can do this next time. But then next time, I guess we'll probably do the, we'll do these things, the labs. So I don't know, I guess we're getting ahead of ourselves. But so now you should understand, you know, if then else, if elif else. And next time, and then after we're done with this chapter, we'll go into loops. So are there any questions? Alrighty. So I will see you on, this is Thursday. I'll see you next Tuesday. Thank you.
Thank you, Professor. Thank you.